Okay.
Okay.
Everyone can hear me?
Uh, yes.
Okay.
Okay, please, Mr. Pratama.
Okay. Good afternoon, everyone. Assalamualaikum warahmatullahi wabarakatuh. First of all,
Waalaikumsalam warahmatullahi wabarakatuh.
okay. First of all, I would like to introduce myself. I'm Aditya Gupratama. I'm a student of Trisakti University. Today, I will present you our research entitled "The Novel Algorithm of Dual-Axis Solar Cycle in Severe Weather." Okay. I would like to start this presentation with this statement. Fulfilling the energy demand by using fossil fuel is still heavily dependent. Energy is essential, but we still rely on fossil fuel. As we know, the fossil reserve is inclined. Maybe in 50 or 100 years, it will be gone. Just in 2018, our oil consumption is over 1.4 million barrels per day. It's a huge number to increase the potential of climate change, increasing the global temperature, and the greenhouse effect. And we know how to tackle all this problem with the renewable energy. And the renewable energy is more than enough. Let's say the solar is more than 10 times what currently wind needs. So speaking of the solar energy, in my country, Indonesia is located in equatorial line. So Indonesia is blessed by the nature. The potential of renewable energy is quite high, especially in solar energy. So it's because the location geographical area Indonesia in equatorial line. But the solar power plant installation currently using a fixed tip angle system. This system is direct the solar panels at a certain angle towards the sun. Meanwhile, the solar panel produces maximum energy while it's perpendicular to the sun. As you know, the sun moves from east to west and also from north to south during whole year. As you can see in your right-hand side picture, the yellow area is the movement of the sun during whole year. Because the movement of sun, we can locate the sun by its azimuth and horizon altitude angle. The altitude angle is the angle between the height of the sun, and the azimuth is the surface of the sun in horizontal way, as you can see in this picture. Okay, because of our system is using the fixed tilt angle system, so and the maximum power is only when it's perpendicular. The fixed tilt angle is only several hours when it has a maximum power. So there is a system, we call it solar tracker. There are two types of solar tracker. The first one is single axis solar tracker and dual axis solar tracker. It can increase the efficiency by 25 and 40 respectively compared to the fixed tilt angle system. So the system can increase the efficiency by moving the solar panel towards the sun perpendicularly in whole day. But many DAST system has unsatisfying result when facing severe weather. Why? Okay, here's the. I will introduce you to about the solar radiation. It consists of two components. The first is direct, and the second one is diffuse. The direct is solar radiation directly touch the surface of the Earth, but the diffuse is solar horizontal radiation is the solar radiation scattered by the molecule or particle, including the clouds. As you can see at the picture A and B, A is during the sunny day. The direct horizontal has more power during sunny day, but in the cloudy day, direct horizontal is lower, but the diffuse solar radiation has more radiation during the cloudy day on severe weather because the solar radiation is scattered. Here's the cloud cover influence on solar radiation intensity. You can see in your left, we have cirrus and altocumulus. It appears when it's sunny day, and right we have altostratus, nimbostratus, stratocumulus, and stratus. It appears in severe weather like rainy, cloudy day. So the solar radiation is so low, it's below 450 or so. So this is our method. Our method is build a new algorithm of dual axis solar tracker, or DAST in short. We call it neo DAST, with the characteristic of diffuse solar radiation. The first is sunlight is captured by the LDR and processed in microcontroller and move the servo motor. So when it comes to the severe weather, cloudy or rainy, the irradiance will be below 450, and the LDR value will below the 900, and the servo motor will, the vertical one, will move to horizontal way or 90 degree. This is the algorithm of the flow chart. First one we compared with the RTC, real-time clock. So we compare the LDR, is it below the set point, is which is 450 watt meter per square. And if below, so the motor's vertical is horizontal way, or it's 0 point. If no, it's so we can say it's sunny day. We compare the north and south LDR. So which one has more intensity? So the more the motor uh, can move to the highest intensity, and also in east and west LDR. So the motor also move to the highest intensity, and the end the solar panel will facing the sun perpendicularly, so it has higher energy to capture. Here's the result. Location test is in Tangerang area, Indonesia. This DST, we using the light sensor is LDR, Arduino Uno as control unit, storage unit and web server, and the lead acid battery as a load. Here's the power output during the sunny or sunny with cloud, because our testing is from March to July 2020. The AC power has more power, is produced 59.67 watt hour, and the fixed rate has 46.51, or the gain is 13.16. Okay, I'm sorry, we're using a 10 watt peak solar panel here. So as you can see in the graph, during the morning and afternoon, the AC has more power, but during the noon, as you can say, there's a jake. The graph is jake because the appearance of the cloud, but it has more power from the fixed tilt angle. Here's the power output during the cloudy condition. The AST has power 38.2 watt hour. In other hand, the fixed tilt angle has 29.84 watt hour. And in short, the gain is 8.36. As you can see in the cloudy condition, is Jake also because the appearance of cloud, so it's below the maximum peak of the solar panel, but the DAST, our algorithm, has more power than the fixed tilt angle by the 8.36 watt hour, higher than the fixed tilt. And here's the output during the rainy condition. It's the heavy rainy condition. The ST up here has 2.5 watt hour, and the fixed tilt angle is 1.95. Organ is 0.55. Because this heavy rain condition is because the presence of nimbus stratus cloud and stratocumulus cloud, so the solar radiation is pretty low. So during the heavy rainy condition, it's too low to generate the power, but our system has more power, slightly has more power than the fixed tilt angle. And here our conclusion, novel algorithm of dual axis cycle was presented. And here's the conclusion. On the sunny or sunny with cloud, The AST has inclination in 59.767 watt hour and 46.51 for the fixed angle. In cloudy weather condition, the AST has power 38.20 watt hour and the fixed angle has 28.84 watt hour. And when it's heavy rainy condition, the fixed angle is 1.8, 1.95 watt hour, and the AST is 2.5 watt hour. Or in short, this proposed algorithm has more power, up to 28% in severe weather. Okay, I think this is all for my presentation. Thank you for attention. And if terima kasih. If anything you can ask or anything is unclear,
Okay.